Hi, everybody. Up to this point, we've been working with a lot of different identities, basic identities, Pythagorean identities, quotient identities, even and odd identities, etc. So in this video, we're going to add a couple new identities to your list, to your toolbox, and those are the sum and difference identities. Basically, sum and difference identities are all of these equations that we use in order to find the exact values of angles that aren't necessarily on the unit circle. So we're talking about angles that might not be pi over 6 or pi over 4 or pi over 3, or even 5 pi over 6 or 11 pi over 6. So all of those are angles that we can figure out either the sine or cosine value on the unit circle. But what we're going to be doing now is we're going to be given sine or cosine values of angles that aren't one of those angles that we've worked with on the unit circle. And we're going to have to break apart those angles that we're given so that we can work with angles that we know. So here are all the equations for the sum and difference of angles. Sine of A plus B equals sine of A times the cosine of B plus the cosine of A times the sine of B, etc. And we're going to go through those for sine, cosine, and tangent, both addition and subtraction. Um, at this point, based on how we're learning, you don't have to memorize them. If when we're in school, that would be something you'd probably want to commit to memory. But for right now, make sure you keep those handy because it'll just be easier to have them in front of you as you're working through these problems. So the easiest way for me to kind of explain the sum and difference formulas to you is to actually just do examples. So in number one, we've got the sine of 105 degrees. So 105 degrees, if we were to consider the unit circle, 105 degrees is going to be over in quadrant 2. So 90 degrees takes us straight up. So 105 degrees is going to be 15 degrees past 90 degrees. The sine values that we're looking for, the y value of this angle, right? So the y value, how tall it is. But we don't know 105 degrees. That's not one of the angles we've worked with. So what we have to do is we've got to split it up into angles that we do know. Now, this is the part that's going to take a little bit of practice, take a little work on your end. So what you're going to want to think about are what are those angles that we typically work with? Well, if we're thinking about the unit circle, even quadrant 1, we often work with 30 degrees, we work with 45 degrees, we work with 60 degrees, etc. So those are the ones we want to try to start to think in terms of. So the sine of 105 degrees is actually the same thing as the sine of 45 degrees plus 60 degrees. If I add together 45 degrees and 60 degrees, I get 105 degrees. I get exactly the same thing. So from here, now I'm going to use that formula from the slide before to solve this problem. So when I'm trying to find the sine of an angle that I can comprise of two different angles, I'm going to use this equation here. That's the sine of A plus B equals the sine of A times the cosine of B plus the cosine of A times the sine of B. So I'm just going to plug these in. So the sine of angle A, so this one is going to be my A and this one is going to be my B. It doesn't matter which comes first, as long as you're consistent. So we're going to do the sine of 45 degrees times the cosine of 60 degrees plus the cosine of 45 degrees times the sine of 60 degrees. So now you need to bring in your knowledge and your memory of the unit circle. So if we're talking about 45 degrees, the sine of 45 degrees, or the y value of a 45-degree angle, is going to be the square root of 2 over 2 times the cosine of 60. So 60 is the furthest one up towards 90 degrees. So if you're using that left-hand trick, you're going to put down your index finger. The cosine of 60 is 1/2 plus the cosine of 45 degrees is also going to be the square root of 2 over 2. And then the sine of 60 degrees, the y value, is going to be the square root of 3 over 2. So now I just have to simplify. Order of operations says that I'm going to do my multiplication first. So I'm going to multiply those two. So I've got square root of 2 over 2 times 1/2 gives me the square root of 2 over 4 plus square root of 2 over 2 plus, times the square root of 3 over 2 gives me the square root of 6 over 4. Now, these guys have common denominators, these two fractions, so I can add them together, but the square root of 2 and the square root of 6 are not like terms, so I can't actually put them together. I'm just going to write them together in the fraction. So this whole thing is actually equal to the square root of 2 plus the square root of 6 all over 4. And that's going to be my final answer for the sine of 105. That then takes us to question number 2. So for question number 2, it's asking for the cosine of 165 degrees. Now, again, these are to figure out the two angles that you're going to want to put together to get to this 165 is going to take a little bit of practice, but just really try to keep going back to that 30, 45, and 60 degree options in quadrant 1. Even if it lets you figure out one of the angles, then you're going to be able to figure out the other one. The nice thing about this is too, there's more than one option. I may separate a larger angle like this into two angles and you might do it differently, and that's totally fine, as long as your steps are correct and we end up in the same place at the end. So for the cosine of 165, I'm actually going to break that up into the cosine of 45 degrees again and 120 degrees. So 120 degrees isn't in quadrant 1, but I'm still going to use those reference angles to try to figure out what my sine and cosine are. So cosine of 45, that's always going to be the square root of 2 and the square root of 2 over 2 and the square root of 2 over 2 for both sine and cosine. That's the easy one. For 120 though, so that's going to be right here. This is my 120 degrees. That has a reference angle here of 60 degrees. So I want to consider my 60 degree angle here, which has a cosine of 1/2 and a sine of square root of 3 over 2, which means that 120 degrees will also have the numbers of 1/2 and the square root of 3 over 2, but my cosine value, because it's x and it's to the left of the y-axis, that's going to be negative. So these are the steps you may want to take before you even jump into the equations. I think it's going to make it easier for you because now I have my two coordinates. I can just jump right into the problem. So here's my equation that I'm going to be using for the cosine, the sum identity, and we'll jump right into it. So the cosine of a plus b is going to be equal to, again, here's my a and here's my b. So I've got the cosine of A, which is 45 degrees, times the cosine of B, which is 120 degrees, minus the sine of A, 45 degrees, times the sine of 120 degrees. Running out of room. All right, so cosine of 45 degrees, we said that that's the x value. That's going to be the square root of 2 over 2, times the cosine of 120. Well, I already did the work. I can look right up into that coordinate that I found before. The cosine is the x value, so it's going to be negative 1/2. Now in this case, it's minus for the sum of the cosines here. So we've got minus the sine of 45, which is also the square root of 2 over 2, times the sine of 120, which we figured out was the square root of 3 over 2. Now I just have to simplify. I'm going to multiply and I'm going to multiply. So I've got negative square root of 2 over 4 minus square root of 6 over 4. So now I can put that all together because it's common denominators. So that's going to give me negative the square root of 2 minus the square root of 6 all over 4. So questions 3 and 4 are exactly the same thing as 1 and 2. The only difference is that we're dealing in radians instead of degrees. So here's where fractions kind of come into play. Depending on how comfortable you are with fractions will determine how comfortable you are with these kinds of problems. But it's the same idea. We're trying to break apart these angles and then figure out the smaller pieces that actually fit on that unit circle. So when we're thinking about parts on the unit circle or angles on the unit circle that we're familiar with, we're going to be thinking about our pi over 6, our pi over 4, and our pi over 3, and then multiples of that. So for number 3, I've got the cosine of 19 pi over 12. I'm going to break that up into 9 pi over 12 and 10 pi over 12. Now, again, you may try something and it may not work, and that's fine. Break it apart, try to simplify it, see if it works out, and if it doesn't, that's okay, just go back and try again. What we are going to find by doing this is that we've got the cosine. Let's simplify these fractions. 9 pi over 12, those are both divisible by 3, so I really have 3 pi over 4, which is on the unit circle. That's my middle angle over in quadrant 2. And then I've got the, 10 pi over 12. The 10 and the 12 are both divisible by 2, so I'm going to have 5 pi over 6, which is also in quadrant 2 with a reference angle of pi over 6. So now I'm going to take my, I have the formula just above. So I've got the cosine of A. So I've got the cosine of 3 pi over 4 times the cosine of B. So the cosine of 5 pi over 6 minus the sine of A, which is the sine of 3 pi over 4 times the sine of B, sine of 5 pi over 6. Okay, so the cosine of 3 pi over 4, again, thinking about that unit circle, I'm in quadrant 2. I know that my number is going to be the square root of 2 over 2 because all of the over 4s are square root of 2 over 2. But because it's to the left of the x-axis, my x value is going to be negative. So the cosine of 3 pi over 4 is negative square root of 2 over 2. The cosine of 5 pi over 6. So this is one we might not be quite as familiar with, so I'm just going to sketch it out. 5 pi over 6 is going to be right over here with a reference angle of pi over 6. So the coordinates for pi over 6, that is going to be the square root of 3 over 2 comma 1/2. So 5 pi over 6 all the way over here, they're going to have, again, the same numbers, square root of 3 over 2 comma 1/2, except my x value is going to be negative square root of 3 over 2. So now I can go back down to my equation. I'm looking for the cosine of 5 pi over 6. That's going to be negative square root of 3 over 2. Now I'm subtracting, so this is minus the sine of 3 pi over 4 is minus square root of 2 over 2 times the sine of 5 pi over 6. That's my y value, so that's going to be 1/2. So now this is going to be equal to a negative times a negative is a positive. Those cancel each other out. So I've got the square root of 6 over 4 minus, this is still going to stay negative, so it is our minus, times 1/2. So this is going to stay square root of 2 over 4. I can put those all as one fraction, so I'm going to have the square root of 6 minus the square root of 2 all over 4. That's going to be your final answer for number 3. On to number 4, we're looking again for two angles that are going to add up to negative 5 pi over 12. If I know that I'm adding and not subtracting, I right away know that I'm going to have two negative angles. So what I'm going to do here is I'm going to say negative. Let's try 2 pi over 12 plus negative 3 pi over 12. If I do this and I simplify, the negative 2 pi over 12 is going to give me negative pi over 6, which is on the unit circle. I can use that. And then negative 3 pi over 12, if I simplify that, I have negative pi over 4. And that is also in the unit circle. So those two angles are the ones that I'm going to be able to work with. So I'm just going to go ahead and fill in the equation. I've got the sine of my A is pi over 6. Sorry, negative pi over 6. Negative pi over 6 plus negative pi over 4. Now remember, when I add those together, technically, once I get my common denominators, that would actually be equal to negative 5 pi over 12. We are going to use the difference formulas as well, but when we have a negative angle that we're trying to split apart, like this negative 5 pi over 12, we can add negative angles, or we could even subtract a negative from a positive. All right, so from here, pi over 6, so it is negative pi over 6, so I've got to consider that when I do my final answer, but let's think about the reference. Oh, let's actually do our equation first. So if I split this apart, so now I've got the sine of a, sine of negative pi over 6, times the cosine of negative pi over 4, plus the cosine of negative pi over 6, times the sine of negative pi over 4. So there's my equation. Now I've got to think about what these values are on the unit circle. So negative pi over 6, if I sketch it out, negative pi over 6 is going to be down here, but again with that reference angle of pi over 6. So pi over 6 is going to give me square root of 3 over 2, comma 1/2. So again, this is going to be the square root of 3 over 2, but I'm below the x-axis, so it's going to be negative 1/2. So the sine of negative pi over 6, that's my y value, is going to be negative 1/2 times the cosine of negative pi over 4. So remember, that's also down here. The cosine is going to remain positive, so that'll stay the square root of 2 over 2, plus the cosine of negative pi over 6. That's just my x value, the angle I already found. So that's a positive square root of 3 over 2. Sine of negative pi over 4. This sine is my y value. That's negative below the x-axis. So that's going to be negative square root of 2 over 2. I go through and I multiply. So this becomes negative square root of 2 over 4 plus negative square root of 6 over 4. Put those together, negative square root of 2 minus the square root of 6 all over 4. And there's your final answer for number 4. Okay, so for number 5, we're going to approach it the same way in that we're going to use this sum identity that I've copied over for you, and we're going to split apart that 13 pi over 12 so that we can have it in terms of two angles that we can find on the unit circle. So I'm going to turn this into, we're going to say that this is the same as the tangent of, I'm going to pick 9 pi over 12 and 4 pi over 12. So common denominators here, 9 and 14, we add them up, we get 13. But now I can simplify these. So this is really the tangent of 9 and 12 are both divisible by 3. So 3 pi over 4 plus 4 goes into 12 evenly, pi over 3. So now both 3 pi over 4 and pi over 3 are angles that we can find on the unit circle. This is where things get a little bit trickier though, because you really have to know your unit circle to be able to find these answers. So let's think about for a second if we've got our unit circle here. So we'll do 3 pi over 4 first. So 3 pi over 4 is this angle over here. The nice thing about pi over 4s is you're always going to have it be the square root of 2 and over 2 and the square root of 2 over 2. So when we're talking about tangent is sine over cosine, we know that it's in quadrant 2, so it's negative square root of 2 over 2, common square root of 2 over 2. That's our point. That's our ordered pair for 3 pi over 4. So if I take sine, which is the y value, and I put it over cosine, which is the x value, I'm going to end up with 1, or in this case, negative 1. So the tangent of 3 pi over 4 is negative 1. Okay, so we have to do the same thing with pi over 3. So pi over 3 is in quadrant 1. Whether you use your left-hand trick or looking at a unit circle, however you're going to do it, the coordinates here, we've got 1/2 as our cosine, and then the square root of 3 over 2 is our sine. So to figure out what the tangent is here, we have to take sine over cosine. So we're going to do square root of 3 over 2 over 1/2. So that gives us the square root of 3 over 2 times 2 over 1. The 2's cancel, and we're left with the square root of 3. So that is the tangent of pi over 3 is the square root of 3. Now those tangent values, I don't expect you to memorize. I think as long as you know sine and cosine and you know how to figure out tangent, I think that's good enough. So we've got our two values figured out. We've got that the tangent of 3 pi over 4 is negative 1, and that the tangent of pi over 3 is the square root of 3. So now let's put this into our formula that we have at the top and see what we can find. So we've got the tangent of a plus b. So a is my 3 pi over 4, pi over 3 is my b. So this is going to be equal to the tangent of a, so the tangent of 3 pi over 4, plus the tangent of b. or the tangent of pi over 3, over 1 minus the tangent of A, which we said was 3 pi over 4, times the tangent of B, which is pi over, times the tangent of pi over 3. The nice thing by doing what we did over on the side already is we know all these values now. So the tangent of 3 pi over 4 is negative 1. So I start with negative 1 plus the tangent of pi over 3 is the square root of 3 over 1 minus the tangent of 3 pi over 4 again is negative 1 times, in this case, the tangent of pi over 3 or the square root of 3. Now we just have to simplify. So we've got negative 1 plus the square root of 3 over 1 plus the square root of 3. Now, if you remember those crazy rules, we can't have a radical in a denominator, so we have to rationalize this. When we have a binomial in the denominator separated by an addition or subtraction sign, we always multiply by the complex conjugate. So we're going to multiply this. To get rid of it in the denominator, we have to do 1 minus the square root of 3. But we have to make sure we're multiplying by an equivalent of 1. So we have to make that 1 minus the square root of 3 over 1 minus the square root of 3. So when we multiply, we're going to FOIL the top. Negative 1 times 1 gives me negative 1. Negative 1 times negative square root of 3 gives me a plus square root of 3. Square root of 3 times 1 gives me plus square root of 3. And then square root of 3 times negative square root of 3 gives me a minus 3. Okay, in the denominator, I'm going to do the same thing. I'll leave the colors consistent this time. So I've got 1 times 1 is 1. 1 times negative square root of 3 gives me minus the square root of 3. And then we've got square root of 3 times 1. So I've got a plus square root of 3. And then a square root of 3 times a negative square root of 3 does a minus 3. So the nice thing with this complex conjugate, the whole point of doing it is I've got a minus square root of 3 and a plus square root of 3. Those cancel out. So now we have to kind of combine all these together. So I've got negative 1 plus negative 3 gives me negative 4. Square root of 3 plus square root of 3 gives me 2 square roots of 3 over 1 minus 3 gives me negative 2. Now I can distribute this or apply that negative 2 to both parts of the binomial in the numerator. So negative 4 divided by negative 2 gives me a positive 2, minus 2 root 3 divided by negative 2 gives me that negative. The 2's cancel out, and I just have square root of 3. So that's my final answer. In these questions, I've got a lot to do. Not only do I have to apply this formula that I'm given, in this case our tangent formula, our tangent sum formula, but I also have to be able to figure out what are my values on the unit circle. So I have to be able to figure out what those are and what those angles can be that I can split that original angle up into. Then once I plug everything in, I've got a lot of algebra to go through as well. And remembering these rules of complex conjugates and rationalizing denominators, and then remembering how I can simplify fractions. So there are a lot of steps to these, but really the trig part of this is being able to take my original angle, separate it into two that I can find on the unit circle, and then understanding what those values are on the unit circle. So hopefully that's making a little bit more sense for you. So now I'm going to skip over to number 7. In numbers 7 through 10, they ask us to condense the trig expression into a single one. So we've got all kinds of terms that are separate. And what we're going to try to do is use these sum and difference formulas backwards. And then we're going to find the exact value based on that single trig function. So if we look at this expression, you kind of have to look at the equation you're given. I'm noticing tangent, so we're going to be using either the tangent sum of angles or the tangent difference of angles. The piece that's going to tell us which one to use is this plus sign right here. If you look at the two different equations, the sum of tangent angles has the plus between the tangent A and tangent B in the numerator, and the difference has the minus sign between the tangent A and tangent B in the numerator. There's also a difference that the signs are switched in the denominator as well, but this is a quick way to look, but you could base it off of either one of those. Either way, we know that this means that this is going to be equal to the tangent of, it's the sum of those two angles, so the tangent of 48 degrees plus the tangent of 102 degrees. When I put those together, I have the tangent of 150 degrees. So that's kind of the easy part of it. You're looking at the expression and you're figuring out which one of the formulas we're given does this fit into, and we're coming up with this tangent of a single angle rather than multiple, so a single expression. But now what we have to do is figure out, well, what exactly is the tangent of 150 degrees? So we're going to go back to the unit circle again. 150 degrees is going to be 30 degrees shy of the 180 of that x-axis. So here's my 150 degrees. Actually, I'm going to move that over here, 150 degrees. So for me to figure out what the ordered pair is over here, I'm going to use that reference angle of 30 degrees in quadrant 1 because that's the one that I'm expected to know anyway. So 30 degrees has the points of the square root of 3 over 2, comma, 1/2. That's my cosine and my sine. So I can reflect that over into quadrant 2, and I'm going to use the same numbers, square root of 3 over 2 and 1/2, recognizing that because I'm to the left of the y-axis, because I'm in quadrant 2, it's going to be a negative square root of 3 over 2. Okay, so now I've got my sine and my cosine. I just have to use that to find tangent. I know that the tangent of x is equal to the sine of x over the cosine of x, or x in this case is 150. So the tangent of 150 is the sine of 150, which is 1/2, over the cosine of 150, which is negative the square root of 3 over 2. To solve for that, I'm going to do keep change flip. So I've got 1/2 times negative 2 over the square root of 3. The 2's cancel, and I'm left with negative 1 over the square root of 3. But I have to rationalize that denominator, so I'm going to multiply by the square root of 3 over the square root of 3, leaving me with negative square root of 3 over 3. That is my final answer for the tangent of 150 degrees. We're going to approach number 8 in a similar way. We're going to analyze the expression we're given. So right off the bat, I'm noticing that I've got a cosine and a cosine, and I've got a sine and a sine. So right away, looking back at the formulas, I know that I'm dealing with one of the cosine expressions. So this is going to be the cosine of something. Now I need to go back and figure out, am I adding or subtracting? So here between the two products, I have a minus sign. Because I have a minus sign, I know that's going to be the cosine of A plus B. It's the opposite for the cosines and it's the same for the sines. So using this expression, I'm going to have the cosine of 300 degrees plus 15 degrees, or the cosine of 315 degrees. So that's great. Now I know what I'm dealing with, but now I actually have to figure out what that is. So back to the unit circle. 315 degrees is going to be all the way around to quadrant 4 with a reference angle of 45 degrees. This is my 315 degree angle all the way around. So 45 degrees, if we remember from quadrant 1, the coordinates are the square root of 2 over 2, comma, square root of 2 over 2. So if I'm reflecting that down to where 315 degrees is, my x value is going to be exactly the same, but my y value is going to have the different sign. The nice thing about this, instead of with tangent, is the cosine is just the x value. So we didn't even really have to go so far as to find that y value as well, but just good practice. So the cosine of 315 degrees is that x coordinate. The cosine of 315 degrees is equal to the square root of 2 over 2. Another problem with tangent for number 9. So again, we know we're dealing with tangent. We're going to have some kind of a tangent expression. We're either going to be adding or subtracting these two terms. We just have to figure out what that is. So we go back to the formula. We've got a minus here, and we've got a plus here. So when we go back to the formula itself, when we have a minus sign or subtraction in the numerator, that means we're going to be doing the tangent of A minus B. So that follows suit. That's the way to remember it. If this is a minus b, that means the minus is going to be in the numerator. So now we just have to plug that in. So we've got the tangent of, our a value is the 5 pi over 18 minus pi over 36. So this one's a little trickier because we don't have common denominators, so we just have to make those one extra step. So we have the tangent of, common denominator here would be 36. So we're going to do 10 pi over 36, multiplying both the numerator and the denominator by 2, minus pi over 36, making this the tangent of 9 pi over 36. Those are both divisible by 9, so that's going to be the tangent of pi over 4. So the great thing about those pi's over 4s with tangent, pi over 4 is the same as 45 degrees. We've got the square root of 2 over 2, comma, the square root of 2 over 2. Those x and y values are the same. We don't have to cancel. We don't have to rationalize. Sine over cosine, these are the same. So they end up canceling each other out, and we're left with just 1. We are dealing with pi over 4, not a multiple of pi over 4. We're in quadrant 1, so it is positive, and 1 is our final answer. So for the remainder of the notes, we're just going to be simplifying these expressions. We're looking to use the sum and difference formulas to combine expressions and make them a little more simplistic, a little less fluffy. But we're not necessarily looking for an actual value at the end of this. So let's take a peek at this one. Right away off the bat, we can see we've got a cosine and a cosine, and then we're adding a sine and a sine. So those are the pieces that you want to look at when you're analyzing these. So the cosine, cosine, sine, sine is the cosine sum or difference expression. The plus in the middle means that we're actually subtracting. We're doing difference of angles on this one. So this is the equation for, this is the expanded expression for the cosine of 2x minus 4x. So if we take that big expression, because it follows that pattern, because it fits into the formula, we can simplify this down to something we can simplify even more. So 2x and 4x, they're now in the parentheses together. It's what we're taking the cosine of, so I can combine those. So now I have the cosine of negative 2x. Now remember that cosine is an even trig expression, so when I'm taking the cosine of a negative angle, which is negative 2x in this case, that is the same as the cosine of the same positive angle. So it can actually simplify that even further than just combining. I can take out that negative because of our even and odd expressions. So the final answer for this, fully simplifying it, is the cosine of 2x. Same idea for number 12. Again, we know we're dealing with a tangent expression. We just have to figure out if we're dealing with a plus or a minus. So to figure that out, we're going to look right in that numerator. We see that there's a plus, which means that we're doing the tangent of a plus b. Those are going to match up. So using the values from the original expression, I have the tangent of 4 theta plus theta. Or when I add those together, the tangent of 5 theta. And that's your final answer. So number 13 is the last one for this notes video. We're going to approach it the same way. First thing we want to notice is that we have the sine and the cosine that comes first, and then the cosine and the sine. So that tells us off the bat that we're dealing with one of the sine sum formulas. So we've got sum or difference. So we've got sine of A and B. Then what we have to look at is what is the sign in between. So since that is a negative, that tells us that we're dealing with the difference formula. So we're going to be dealing with sine of A minus B. Switch back to the pencil. A minus B. So in this case, it's going to be the sine of pi over 2 minus theta. Now, hopefully alarm bells are going off in your head because this is another identity that we've worked with in the last few weeks. This is one of our co-function identities. If you look back in your notes, you're going to see that the sine of pi over 2 minus alpha is actually the cosine of alpha. So that can be simplified one step further by recognizing that that is another identity expression. So that is it for this video. I know there are a couple problems in the notes that we didn't go over, but hopefully based on the work that we did, you feel pretty confident in going in and working on those on your own. Please be in touch if you have any questions, and good luck with the rest of the assignment.